Now we can begin the session 2, Understanding Artificial Intelligence and its Use in Analytics and Audit. We have speaker, CA Babu Jayendran. Over to you, sir.
I'm coming out here because I can't still stand at the back with the laptop because I need to keep putting on my specs if I want to read out of the laptop. So I said, instead of spending half the time doing this, let me at least use it properly to talk to you. Right? So I'm going to stand here and use my pointer and then explain whatever I have to. So, it's really nice to see all of you here, and Rafiq has laid the foundation for data analytics and artificial intelligence and audit intelligence. Hopefully I'll try to take it to the next level. I must warn you that in this area of artificial intelligence, the big difference between data analytics and artificial intelligence is that what Rafiq taught you today morning, you can actually go and try it out tomorrow in the office where you're working. You can't do that with AI. Because for AI, you need to have a handshake with high-end artificial intelligence programmers, right? And it involves a lot of high-end mathematics. However, having said that, I'm not in any way trying to dissuade you. I'm trying to do the opposite. As chartered accountants, you will realize when I go through this, there is a huge amount of knowledge in terms of business processes that you have. And it is just sitting in your hard disk called your brain. You've got to use it for AI. If you don't use it for AI, you will only get artificial intelligence solutions which will identify whether a photo is a cat or a dog, things like that. You've got to use your knowledge. You may not realize the knowledge that you possess, but as we go along, you will understand what I'm trying to say. So, this is the this is the agenda. First, we'll go through the basic concepts of AI neural networks. And the reason why I'm saying that these basic concepts and overview is extremely important in this very, very abstract area is that unless and until you understand what artificial intelligence from a technology perspective is doing, it is very, very difficult for your mind to open up and start thinking out of the box. Because you have to start thinking out of the box based on what I'm going to tell you on how AI works and then how it can be used by CAs. Then we'll go through this relevance of AI and analytics for CAs, the need for using pattern recognition, practical examples of AI in banking. And this also I am telling because I was very, very lucky that in 2007, way before people started talking about AI and all that, I was involved with another tech friend of mine where we created a product using neural networks and artificial intelligence for anti-money laundering in banks and catching frauds in banks. It took us nearly 4 years with about 30 programmers to create that product, and it is out there running in markets in India and abroad. And it is that experience that has absolutely convinced me that this is for real. This is not fiction. Okay? It is not what you see in Star Wars movies, etc. This is something that you can actually use and use your knowledge which you all possess and huge volumes of information that you possess from a business process, domain, risk side angle and try to bring that out. Then this is what I meant, using functional knowledge to create learning algorithms in AI, then the art of identifying suspicious transactions in a P2P. I've just taken purchase to pay cycle, and I've just taken 3 simple examples so that if I plant that seed in your mind, I presume it will nurture and you can take it to the next level. And what is the road ahead? Okay. I find that this projector is not giving the colors which is supposed to show, because there are a lot of places that I had highlighted certain words in red. Apparently the red is not coming up. I don't know whether it's a cable fault or, because even when you were talking it was flashing. Can someone just push this cable properly?
No, it's not okay.
Huh? No, one pin I think is gone. So anyway, I will, this is called there was a professor called Alan Turing, and in 1950 he brought this thing called the Turing test. It's a test of a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. So if you are sitting here and there is a computer and there is a human being there, if you cannot make out that the response that you're getting is from a computer or from a human being, right, then you have passed the Turing test. A great example today is chatbots. I'm sure you all must have all experienced chatbots, because sometimes when you go to a website, you will get something popping up on the right, and then it will ask you questions and then you reply. Most of the time you're talking to a machine. Okay, there's no human being at the back. So that is what the Turing test is supposed to do. Now, if you take traditional systems vis-a-vis AI, you will notice here in traditional systems you have data, you have a program, you have a computer which will give you an output. In AI systems, this program and output will switch. You give data, you give what the output should be to the computer and it will generate the program. This is the big difference. This is, it looks very, very simple here, but this is the difference. So for example, if the data is millions and millions of photographs of dogs, right? And I tell the system that all these photographs are photographs of dogs. And I give the feature vectors saying that a dog has 4 legs, right? This is the way the face will look. This is the profile. All those vectors, if I give it to it, right? And I say that anything that looks like that, the output will be dog. If I give photos in an image recognition software using AI, it will identify whether it's a cat or a dog or a bird or whatever it is. Because of the fact that most of the tech evolving out of AI has been created by companies like Google and DeepMind and all these high-end tech companies, most of the AI work has been in the area of text processing, image processing, natural language processing, translation, etc. Okay. The area of business has not come that far because people like us have to get involved in that. So if you understand this, you will be able to understand the power of AI, as we go along. So what is artificial intelligence? Today you have machine learning, deep learning, predictive analysis, then speech, you have text to speech, speech to text, vision, image recognition, machine vision, then NLP, natural language processing, you have classification, translation, data extraction, expert systems, planning optimization, and robotics. Now, in all these areas, This machine learning which I am talking about, this one, this deep learning and predictive analysis and all, it is now catching on in the business area. Otherwise, these things have gone forward a lot, and I'll show you one slide for that. Yeah, this is what I was talking about, the AI streams. So if you see these AI streams, this is artificial intelligence. Machine learning, deep learning and predictive analysis, technology-wise, has reached quite a lot. You can see from the line that it has gone far, far beyond. In natural language processing also, it is going quite far. Translation, they have mastered translation today, where Google has created a mic-like thing where if you talk to a person in English and there's an earphone, and if you're in Japan, it is instantaneously translated to that person in Japanese, and that person will communicate in Japanese, and it is instantaneously translated in English to you. So you can actually have a one-on-one conversation with somebody else. So that has moved far, you know. Now, if the blue thing which I put here, expert system, you see that the line is just stopping here. Planning, scheduling and optimization. Whereas vision, like image recognition, Facebook today uses image recognition quite a lot. And you know, all this has moved, but this is not moved much. The reason is, for this you need domain knowledge. So if, for example, AI has to move in the area of auditing, chartered accountants have to give the learning algorithm. If it has to move in the area of insurance, insurance specialists have to give that domain knowledge. If it has to move in the area of retail, retail specialists, and when I say specialists, they must be top-notch experts in the area, right? Otherwise it will not move. So this is the area that all of you sitting here can definitely contribute. Now, let me give you a very simple example that you all know. This Netflix, how many of you watch Netflix? Yeah, quite a lot of you watch. Every time you go and watch some series, you'll get a message of some other movie that you should watch, which is similar to the movie that you watched. And it says recommended for you to watch, right? How is that done? That's through AI. Okay? That's how it is. Amazon. You go and buy one smartphone, immediately you will get some recommendation of similar type of phones. All AI. Now, there is a fund in the US called the Renaissance Medallion Fund. The founder is a PhD in mathematics. His name is Jim Simmons. Anybody interested, please go and Google and watch his talk. It is really, really worth listening to him. He's actually he's a PhD in geometry, surprisingly, okay? And what he did was, he realized the power of computation and AI and things like that long before anybody even realized the power of it. He used it. He started a company called Renaissance Technologies, and he started a fund called the Renaissance Medallion Fund, which is available only to his staff. Nobody can invest in this other than his staff. He has got 300 staff. Out of that, 90 are PhDs in mathematics, physics, astrophysics, etc. All the high-end mathematics required for artificial intelligence. From 88 to 2016, this is a graph of his company in Bloomberg. You will notice he has given 50% return throughout. He has even given a return which was close to 80%. And he says, one thing we have learned is don't override the machine. They did it once and they made a mistake. So he's telling now we don't override the machine, whatever the machine tells to buy and sell to. Okay? Now, this is a real life example of success using AI. Okay. Now, he could achieve it because of the tremendous level of competence that he has in his organization in terms of mathematics. AI boils down just nothing but mathematics with domain knowledge. That is the combination. If you take Tesla, you got assisted driving. Everybody knows about that. Okay, you have driverless cars. Whether I'll get into one of them, I doubt. I wouldn't trust any of this, driverless stuff. In fact, if you go to Dubai, any of you have gone there, that metro is a driverless metro. I get pretty scared jumping into that. So, sometimes because these program bugs are always there. And as you know, the Lion aircraft which crashed into the Java Sea was the latest 777A series. Okay, it went up and it went down because of a manufacturing defect from Boeing, where the information from the wings was not being passed on correctly and it was giving the wrong values. And it just went up like that and went right down inside. Okay, so the only place where it is zero tolerant in programming and which I've seen which is successful is our GSAT launches and NASA. Because they have to be zero tolerant, because if they're sending a person to space, you cannot have even one error. Okay? Those are zero tolerant. But I don't think normal people who are writing AI programs, there's going to be bugs. Let me tell you that for sure. Okay? Bugs are always there with programs. And of course, IBM Watson is for the, cancer diagnosis, and in fact, even in Manipal Hospital and all that, they're using Watson. So if you're going with some sort of a disease like cancer or something, they use Watson. Watson gives you give your patients, what the illness is all about and all the symptoms and the lab tests and all that. You feed it into Watson, and then Watson will tell you what could be the problem. And so a lot of hospitals in India also have tied up with IBM Watson. And if anyone wants to use it, I think they give a 1 month free trial. It's worth, you should try it out once. Reason I put this is now to explain to you how this AI works. This, the neurons that we all have in our brain. Okay, and we have, normal human beings have about 100 billion of them interconnected. And it sends electrical charges from one to the other. This is the way in which we understand. Okay? So say for example, I look at Rafiq. That image comes into my retina. Okay? My retina just only captures that image of Rafiq. But through the optic nerve, it goes to a place which is your one cortex for vision, right, which is in your brain, which also has stored information of Rafiq in my mind. So because of that, my system will tell me that this is the information that is stored, this is the image that I've got processing, this is Rafiq. Okay? Now that is how these neurons keep firing in the brain from one to the other till it gives you a result. Now if I am looking at someone who I have not met before, it will just tell me man, woman, that's it. Because there is no other information stored. So what experience and knowledge that we have based on what you learned in your school, from your adult life, in your colleges and in your work, and whatever experience and knowledge that we have, which we call in one word as experience, right? For machines, it is data. What experience is to human beings, data is to machine. Today we can do in AI because there are volumes and volumes and trillions of data available. At the last count I was seeing in the GST network, the count, I think, of invoices uploaded has crossed 1.6 trillion. Okay? That's a huge amount of info and data. You can imagine 5 years down the line, the amount of data you're getting, invoice by invoice, product by product, the amount of analytics that you can do using that data. You can find out so many types of patterns from an economic standpoint. Okay? So, today we have very, very powerful machines also which can handle these large volumes of data. So, what neural networks does is basically it mimics the human brain. And I've said here, the neural network that it, set up data by using a process that mimics the way the human brain operates, and it has the ability to adapt to changing input. What do I mean by that? In neural nets, it's like the human being. Supposing I'm an auditor. I go and I check something and I think it's a fraud. So I go get the documents, I go and verify everything, and then I find out, no, it's not a fraud. It's a genuine transaction. The next time I see that, I will not pick it up as a fraud because our brain has learned. The neural network is exactly like that. It will learn on its own. So if in product you go and say that something is a genuine transaction in a system, next time the same pattern will not be shown. Okay? What these patterns are, I will give you examples by showing real life examples from the software that we built. Now, I showed you that biological neuron which is getting neurons, these are like every circle here which is called a node is the equivalent of a neuron, okay, which is in our brain. So we get input like this, it gets processed one neuron to the other and it goes right till you get an output. The difference in machines is it only understands zeros and ones. So if I give an input here and it goes and writes into this, the output will come as a 1 or a 0. In the brain it comes as an electric charge. So when I get an output, it sums up all the electric charges and tells you whether the decision is to the affirmative or not. Similarly, in this one it will come out with a value, with 1 or 0. Now, why is this so powerful? The reason why this is so powerful is that we can, this input here, which is on the left hand side, can be n variables. Whereas a human beings, maximum we will work is info cube. Maximum we can do is Excel, which is 2-dimensional, or we can work on info cubes, which is 3-dimensional. Our mind cannot process more than that. But a machine, you can plot based on 7 variables, 8 variables, things like that. So if I have to give you an example here, okay, on this, and I'm doing it for a bank, one of the inputs here could be the deposits of a customer per week. This next one could be withdrawals of a customer per week. Next one could be deposits per month. Then next one could be withdrawals for the month. Then one of these could be IP address of the ATM from where they are withdrawing. Another one could be which channel he is using, right? So you can imagine if I am having this many choices in terms of entering to find something, it is very, very powerful. And when I show you the example, you will realize it. Now, these are names, these I'm putting here only just for you to understand, because you may come across this when you're reading something. If you want to get into this area, you definitely have to read a lot. and you have to go and watch, YouTube videos and things like that. But that neural network which I was showing you here, in this one, you will hear a lot of jargon in this world. Artificial intelligence is the superset. I mean, that is the name of this area, what we are talking about that. Below that, you have machine learning, and below that you have what is called deep learning. What is the difference? If I have here, this is a single layer. If I have many layers here, right, it is called deep learning. That means I look for something here, I see it is positive, then I use that information to look for something else, I find it positive, like that. I keep going on till I narrow down on it. It's like looking for a pin in the haystack. Let me explain this to you in a simpler way for you to understand. Take the phishing attack in a bank. What is it happen? What happens? Say I'm hacking into Rafiq's account. Okay? First thing I do is I get his user ID and password. Okay? Then I get into his account. What is the first thing I would do? First thing I will do is I will go and change some static data on his customer profile. And what will I do? I will go and change mobile number so that he does not get SMS. Right? What is the next thing I will do? Soon after I do that, I will go and add a beneficiary that is not there in the previous list of beneficiaries. It may be my name or it may be somebody else's, right? That's what I will do. And all this will be temporal. When I'm saying temporal, it means it will have a time factor. After I get into his account, within 5 minutes to 10 minutes, I will go and first change the static data. Within another 10 minutes, I will add a beneficiary. Then there will be a delay of 2 hours for it to get activated. Right? So I can say after 2 hours, 90% of the account I will withdraw to new beneficiary. Right? This is a simple example I am giving you. To new beneficiary. This will be the thing. All this you can do with AI. You can look for patterns which are also temporal, which say that this event happens, followed by this event after so many minutes, followed by this event after so many minutes or hours. Like, look for these patterns. Right? I hope you got the point. So, in feed-forward neural networks, that information which is in this one will go only one way. It will go like this, right to the output. In this recurrent networks which I am saying here, this one, it gives a loop. Now, where is this used? In this recurrent neural network is for predicting the next word in a sentence, right? So, you will notice when you're using your phone, you just enter a sentence, the next word is immediately prompted. Because now AI chips are being put into phones also, right? It is prompting that next word. But it cannot prompt that next word unless it knows it has to get the feedback of the first 2 words of that sentence. In isolation, it will not be able to prompt. That is where recurrent loops are done. That means it will get from here, it will get the information output here, it will send it back here. Yeah, and then it will keep on doing this recurrent loop, till you get. So it is used for natural language processing mainly. In this convolutional neural network, the CNNs, this is mainly used for image processing. Because of this, it is using, like I was explaining to you, this visual cortex and all that, right? So it is using for. Now, you may be wondering, why am I saying all these things? If you're getting into the AI space, you are going to work with techies, right? You should be able to communicate. At least you should be able to know what is he talking to you about, right? And if you want to be an advisor and you want to do, even to an organization, you should be able to know that what the tech people are doing is the right thing for your solution. for chartered accountants. Okay, let's see, this is how we started, right? It was all descriptive. These were the early days, what happened and why did it happen. It was all standard repos, ad hoc queries, it was all post-mortem, right? Everything in audit was the rear view mirror, right? Nobody had a windshield view of the front. Everything was post-mortem, right? So this is the way things used to happen. Standard repos, ad hoc queries, statistical analysis, etc. Now, in this prescriptive is how to make it happen. So I don't think the people at the back can read this. I'll read it out. Analysis that suggests a prescribed action, like you have business intelligence, heuristic methods, optimization. Then we come to predictive, that is forecast future performance. You have forecasting, predictive modeling, and simulation. And cognitive is what's happening now: AI, machine learning, neural networks, deep learning, pattern recognition, etc. This is the way forward. Now, if you see this, these are the problem types and analytic techniques. I have deliberately put this in here. These are the main things you find in AI. Classification. It just categorizes new inputs as long as belonging to one of the set categories. That is identifying whether an image contains a specific type of object, dog or a cat. So if I am having a lot of images, I can classify it into different things. Now, here comes the maths. This area, which is technique, is high-end mathematics. I put this here so that you know where you draw the line. You know, this is CA's job, this is programmer and AI job. If you want, you can get into it, because it's very exciting for anybody who likes maths, right? It's wonderful if you go into this area, if you like it. But let me warn you that this is maths at such a high level that it can absolutely send you on a tangent. And then you will get the fear of AI and you will not go nearby. So, don't go this side. You want to learn about it, whoever likes to learn about it, go to YouTube, watch the videos, right? So, now in order to do this classification, they use this convolution neural networks and logistic regression, because I said this is for image processing. Logistic regression. For this continuous estimation, this is to estimate the next numeric value in a sequence. This prediction, particularly when it is applied to time series data, that is forecasting the sales of a product based on a set of input data such as previous sales figure, consumer sentiment and weather. Walmart in the US will move umbrellas to Boston from their warehouse in some other city based on the weather channel saying that it is going to be a thunderstorm in Boston. Okay? Like Walmart systems are integrated even with the weather channels. So that is the type of information and prediction that they do. Now, in order to do this, you've got to, if you see here, you use the feed-forward neural networks and you use linear regression. The clustering is individual instances have a set of common or similar characteristics. That is creating a set of consumer segments based on data about individual consumers, including demographics, preferences and buying behavior. Now, there is K-means, affinity propagation, there's another thing, all these math stuff, right? Whoever wants to know what K-means and affinity propagation is, and even for the programmers, let me tell you that it's not that they're going and writing code for K-means, right? It's not they're going and physically writing codes for logistic regression or linear regression. Google has come out, there's a company called TensorFlow by Google, which has already built in these Python algorithms. You have to just call it. So, the good thing with this AI, you see AI code, unlike the code that you see in normal businesses, which is huge, right? The artificial intelligence fellows, when they're coding, is very, very less. Because all they're doing is they're just calling these different tensors which are already built by Google, right? However, it is like a jigsaw puzzle. In order to know what is the algorithm that you have to use, right? The domain person only must explain the scenario. Otherwise, the programmer will not know whether he's got to use classification, whether he's got to use clustering, or whether it's continuous estimation. He won't know, he's just a programmer, right? The challenges that you will have is to find this resource of AI programmers, okay? Everything that I've written here, if you notice, you have the knowledge. And I'll show it to you when I'm doing purchase to pay. The 3 examples in purchase to pay, when I explain that, you will all realize that each and every one of you have the knowledge to create that algorithm. So here what happens is, in anomaly detection, determine whether specific inputs are out of the ordinary. This is usually done for fraud detection, money laundering, etc. And we have used this. We have used software, the support vector machines, k-nearest neighbor, neural networks. We have used all this for this money laundering in the product that I was telling you about, right? So this is used for auditors. Will definitely have to know this. You don't have to know this part of it, but you'll have to use this. Then recommendation. This is like Netflix. For that they use this thing called collaborative filtering. I put this here only for you all to realize that this yellow part, which is here, is your contribution, right? So that you know very clearly where to draw the line. So, if I'm going into forensics, say in a bank, where I have been involved in that product, we had to do all this stuff, and these are real from the product itself. We had to make sure that we had to use business intelligence, that is data analytics, data mining, statistical analysis, rules, rule builder, geospatial analysis we needed because of the fact that we need to know the distances between ATMs, machines based on the IP address to see whether there's fraud, and I'll show you an example of that. Then neural networks, we had to use artificial intelligence, burst detectors. See, if I have to take money laundering, one of the most important things in money laundering is to see bursts. Sudden change in activity and behavior of the customer, right? So for that, artificial intelligence and neural networks is the best. You cannot get a substitute for it. So clue detectors, then we have the money laundering fraud scenarios, memorizer. Then of course you have to do profiling of the customer, etc. And you have to have a case management tool so that the case management workers, like the chartered accountants, the auditors and all that, they can work on it and they can get all the details of the exceptions. So now leveraging the CAS skills, this is what I've been telling you. How you can use yourself for AI. Expert domain knowledge in finance, audit, taxation. Now you can use AI in any of these areas. And like Rafiq also mentioned it, after demonetization, the Indian government has used it extensively for using artificial intelligence. They bought SAS, and I don't know how many of you saw the RFP. It was such a wonderful RFP that they had put out by the income tax department, and it was so well written. They were looking for consultants who have worked in the artificial intelligence space, and they have used it extensively, and that is the reason why you will see that a lot of notifications are coming out now, because their analytics work, I think, is over, and now they're sending out, all the queries and things like that. So if you're a finance person, you can use it there. Audit means you can use your audit domain knowledge for AI. Excellent understanding of business processes. I think no other profession, not even MBAs, understand business processes the way we do it. And the reason why we do it so well is because from the time you join for your articles, all you're doing is tracing data from source to financial statements. That's all we are doing. We have lost it now, especially people like me with grey hair. Everybody else in my generation will realize that in those manual days, of accounting, you had to trace it, right, all the way through ledgers and books till it hits a financial statement. But today, a lot of it, the system is doing the debits and credits. So, you know, you might get lost in that. Then in-depth knowledge of risks and controls. They have forensic experience to identify suspicious transactions. So, if you have worked and done a lot of audit and you have done a lot of forensic audit and you have identified or you've got a fraud, that knowledge must be passed as a learning algorithm into an AI system to catch it. That is the knowledge that you've got to pass. Then today you have, there's availability of large volumes of historical data and availability of powerful computing resources, and expert functional knowledge of CS coupled with AI technology can help in discovering patterns for cognitive analysis. So need for using pattern recognition in audit. So this is how we started. We start with data, then we had MIS reports, we had BI, then we had AI, forensics, and now we are looking for patterns. If you're talking in audit and if you're talking in terms of frauds, every fraudster, there is a pattern to the way in which he commits his fraud. And it is always based on a timeline. Nobody comes to the office in the morning and says I'm doing a fraud and leaving by night. That is a burglar, that's not a fraudster. Okay? But a fraudster, whatever it is, whether it happened in Enron, whether it happened in Satyam, whether it happened in SocGen, Society General, all of them have a time frame that they did it over a long period of time. Because normal fraudsters, the way they work is, they will always do some test runs to see whether somebody is picking up or catching him, and then they go for the big ones over a period of time. So, if there is a timeline, a machine can catch it. That's a fundamental thing. We can catch that pattern provided we think like that and we actually code it in such a way. So like in pattern recognition, I was mentioning to you about this number of variables. Right? In AI, we can use multiple variables. So for the banking software I was talking about, like for a customer salary account in a bank, if I'm doing a pattern recognition for that account of a salaried employee, I would look for multiple credits in the account other than salary credit. Right? I will sizable increase in cash to non-cash transaction ratio, large cash deposits and cash withdrawals. Many transactions with a few related accounts, burst in deposits in number of transactions, burst in withdrawals in number of transactions, burst in deposits amount, burst in withdrawals amount, unusual applications for demand drafts against cash, and transactions that are too high or low in value in relation to customer's profile. There is no way you can even plot or work on Excel with so many variables. Right? But if all these things are happening together, there is a very, very high potential that it is a fraud. So what AI does, it reduces a lot of false positives. Okay? And it will actually zoom in and pick the transaction that is fraudulent. Now you may ask me, how is it plotted then? Okay, I'm not going into the technical details of that. In AI, there are methods in which this is plotted. There are maps which are created, which will do this classification, clustering and all that, based on color coding and whatnot. So we don't have to, but we can't visually see it, right? So whenever you have to talk to normal, like if I make a presentation, I always make it in a two-dimensional XY graph. Right? I can't show that how it is in an AI system. Now, this is source is from the CPA Journal 2017. they are using textual analysis for audit evidence by identifying related concepts or topics, that is people, place, events, then extracting emotions, anger, joy, sadness. So the input is press releases, regulatory filings, management minutes, earning statements, etc., contracts, etc. The output is emotion, sentiment, concept, topic, entity, keywords. And the audit procedures, inspection, analytics and confirmation. So they will do sentiment analysis, they can make out based on certain keywords on the emotions when the minutes of some meeting is being documented, which is very, very difficult for any auditor to sit and read, minutes after minutes and trying to figure out how the emotions work, right? But based on certain keywords, you can do this type of, emotion analysis. Then they use a lot of voice analysis. The language, see, for example, the use of the term that suggests uncertainty, such as kind of, maybe, sort of, should be signs of concealment or falsification. So in input, it is like interviews, conference calls, phone calls, project meetings, presentations. Output is risk of deception, emotion, sentiment, concept, topic, entity, keywords. So this the procedure is inquiry and inspection. So like we auditors, normally we go and talk a lot with people, right? And we get a lot of information doing that. So you can, through voice analysis, you can get all this, all these things on deception and things like that. Then image. So this one is deep learning algorithms can identify model, quantity, condition of inventory of an image from a video filmed by a drone in company's warehouse. So this is very commonly used today because of IoT. And in the Internet of Things, everything is connected. Like our phone, is connected. You can have smart meters in for your electricity consumption, like that. In one of the real life examples of this image and video analysis is in Indonesia. SAP has done with drones for their palm trees. There were a lot of palm trees because they're a large producer of palm oil. So there are hectares of palm tree estates, and this IoT goes and maps every single tree, and they're able to monitor at the tree level based on the information that it is passing back in terms of the amount of water that has been supplied, and the productivity of every single tree is monitored using drones. Now I'll give you the examples I was talking about. This, don't get confused with this. I put this so that I can show you the flow. Now, if I install this AI anti-money laundering software in a bank, let me explain to you what happens so that you know exactly how the patterns are picked. This is the bank's data, okay, which is coming from their core banking system. The core banking system can be anything, whatever they're using. It can be FlexCube or it can be Infosys Finacle or whatever it is. So I have the customer data, I have loans, I have all the other data like retail, this thing like depository, trade finance, loans, forex, all this from the subsystems of the core banking system. I will pull it into my software. Now this one where I am saying here data warehouse, let us say is the software which is the AI software. Now what do we do? If a bank is having, let us assume, some 10 million transactions a day and 20 million customers, what we will do is, we will take for the 20 million customers at 10 million transactions a day for 365 days before the implementation. We will take it and we will send it through this neural network which is sitting here. So it is like for 20 million customers, 10 million transactions a day for 365 days is being sent through my brain, and my brain is mapping every single customer's deposits, withdrawals, deposits per week, IP address of the ATMs, the channels which he is using, whether he is using internet banking, whether he is using across the counter, everything what we define in the learning algorithm, it will map it and it will store it. Okay? Every time another transaction comes in, it will compare with that, and if it is a non-linear outlier, it will throw it out. Okay? Now, I will give you an example of the power of this vis-a-vis how it was done before. I went to a bank where they were running a money laundering software which had one rule there which said, if there is a 500% increase between yesterday's balance and today's balance, it is a burst in deposit and it should be suspicious. Right? This was a very simple rule, which is nothing but an algebraic equation. Now, you imagine a person who is getting 70,000 rupees salary a month. Okay? He gets the month 31st, it is credited into his account 70,000. By the time he pays his EMIs, house expenses, everything, on the 30th of the month, the day before that, right, it will be 7,000, 8,000, he must have just made ends meet. You take 7,000 and see 70,000, it will be more than 500%. Right? System will show as burst. Full false positives. Right? Now, because of that false positive, these case workers don't want to work on it. Because they are so fed up, everything is wrong. Now, in a neural network, this will never happen. Why won't it happen? Because when it is plotting the graph on just these two values that I'm telling, it will have a time scale like this, and if I have amount on the y-axis and a simple graph, I'm saying amount on the y-axis and date on this x-axis, on the 31st it will show 70,000 deposit. Then it will go down till the next month 30th, right? Then again you get 31, it will go up like that. Then again it will go down like this, right? Only an outlier out of this will be treated as suspicious. Are you getting the point? Yeah? Only the non-linear outlier will be suspicious. So so you can imagine this is extremely powerful. Right? I have given it to you as a very, very simple example. But it is used in much more complex manner. And then you get it all here into the, So this is exactly what I was trying to tell you in an animation format. So you have these yellow transactions coming in from this side. Actually the colors have all gone topsy-turvy because these yellows which are coming out here are supposed to be green and these blacks are supposed to be red. Okay, for the good and the bad transactions. But this projector has let me down. Okay, so anyway. So what happens is these transactions keep coming like this and it goes through these type of filters, right, where the rules are given for detection, and then you do the profiling, you do the detection logic, then you get a combined score, statistical functions, everything, and then the red ones, which is not red in this, which is black, are the ones which goes to case management. Okay, so where does the chartered accountant come in? The chartered accountant comes in to give all this logic, these rules, this profiling, this detection logic. What is the definition of burst? Right? Only we can do it. Nobody else. Right? So, if you're a chartered accountant who has done bank audits for many, many years, you can imagine the power of the knowledge that you possess. Right? Which is simply storing in your brain, which should be transferred to a machine so that country can benefit and banks can also benefit. Right? So this is what I want to highlight to you so that you can, leaving this place, think in these terms. So say for example profiling. Okay, this is also plotted by, like, this is again done on an XY graph because we can't show you the AI map on this. So if you take this one, like EFTs, electronic fund transfers, and this blue is ATM and this yellow is check, right? You will note that this person, Joe, is doing most of the the ATM transactions later in the evening. Okay? He's not doing anything here in the morning time, early morning. So if you see some transactions which are coming here in the early morning time, it will be an outlier. It could be somebody trying to scheme your account or something like that. Right? Like I'm staying in Richmond Road. I may be withdrawing say 5,000 rupees a week from the ATM which is on Richmond Road. I know the IP address of the Richmond Road ATM. I know the time. I do it when I go for morning walks. So I know the time is between 6 and 7 in the morning. I know that during the whole month my withdrawal will be so much. Right? This is a pattern that can be obtained about my account if the bank uses neural networks and maps my account. Suddenly if they see some 20,000 rupees being withdrawn in say Guwahati in the middle of the night at 12 o'clock, it could be somebody has skimmed my car, or I have gone there for a wedding, and I am partying there, but at least, so you know that this is happening today in the credit card world. In the credit card world, if you go to say Bangkok and you've never been to Bangkok and you come back, you get a call. Have you gone to Bangkok? Have you used the card there? This is all through neural networks. So these are some of the examples. I told you these are real life examples. The people at the back, I'm sure you can't make out this, but I'll read it out to you. This is a salary account. Okay, I gave you one scenario of salary account. Okay, where I told you deposits we are looking. Look at this account. This is a salary account. Every single thing is cash deposit. Here it says deposit. It is all cash deposit. Not even once there is an electronic transfer into this guy's account. Right? And you will see here all the deposits are below 50,000. It's all 49,000 because of PAN number. Right? Now this is a pattern that the machine has told me. Right? I have not picked this. The machine has told me that look at this pattern. This is 49,000. And what is happening is when this 49,000 has reached a substantial amount, there is a transfer by DD to Guntur. Okay? Now, this guy's account, if you normally see this guy's account, it didn't have this. This came as a sudden surge. Right? Suddenly it happened in between. Now, similar to this, there was another case that we found where the KYC was done in the western part of India, right? And we found the system showed us a huge burst. Don't worry, I will 100% stop at 1. I will make sure that you all go for lunch because I am very paranoid about timings. Okay, I will stop at 1. So, yeah, but I'm just trying to tell you as much as I can. So, what we found was the KYC was done in the eastern part of India, in Bombay, and the system showed a huge burst. Like we have a graph also in our product. So if the line is coming like this, it started going up and down like that. So it was like an ECG, So I mean, even the caseworker, it was like his ECG. He must have got a start of his life just seeing that. And what we do is we also have deposits in brown color and we have withdrawals in blue. So both are going next to each other, up, down, like that. What that system showed us was, there was a sudden, during a period of 2 weeks, there was a huge deposits of 49,000 rupees, of about 50 deposits in cash per day. Okay, in one fellow's account. And that was withdrawn within 1 hour from the eastern part of India in Kolkata as 10,000, 10,000, 10,000, 10,000, and then not 9,000, leave some 5,000, leave some little listing, and 45,000 is being withdrawn from the western part of India, eastern part of India. Now, the coincidentally, because we had the IP address of the ATMs, it was all on the same railway track, okay, which is going towards Bangladesh border, that railway track. So we had, so the person was apparently, in one station withdrawing 10,000, getting off in the next station withdrawing 10,000, like this. Now, there is no way, with hundreds of auditors, you could find this. It is impossible to find a pattern like this where the time factor, everything is correlated and it is telling that something is wrong in this account. Okay, so now if you see this ATM and geospatial analysis, you see this analysis. Withdrawals at 3 different ATM locations at the same time, even the second is the same, and these are 3 different locations, physical locations in Bangalore. Impossible. Right? So, look at this. Withdrawals in 2 different cities in a span of 12 minutes. One is in Bangalore and one is in Hyderabad. Here. Hyderabad, Bangalore. Impossible. So, now this is all because you are doing geospatial analysis, you have got IP addresses of ATMs, you know the distances between ATMs, you can do all that, right? Look at this. I mentioned when I started in the overview of the program, I said that 80% of those respondents said that you shouldn't just work on samples anymore, the auditors must do the whole transaction, right? In these type of analytics where you're using AI, every single transaction goes through it, right? And it doesn't make a difference whether it is material or not, because in fraud, whether you steal 25 rupees or whether you steal $1 million, a fraudster shouldn't be in your company. He should be out of company, right? So there's no materiality concept for fraud. In this, we found in one chap's account, 112 times 25 rupees have been credited on the same day and similarly for every month. And the description is given as puja deduction. When we found out what this guy was doing, it was an employee's account. What he was doing was that the checkbook was 25 rupees. He used to debit the customer and credit his account instead of taking it into income. Okay? Why did he do it? Because I believe that auditors check the effectiveness of controls and fraudsters check the ineffectiveness of controls. The reason he did that is only because of the fact that the co-banking system that they were using, the drop-down menu gave the names of the customers and the ledger accounts in the same drop-down. And he realized that. You don't get that in Finacle, you will not get that in FlexU. But in small banks, they use some vague software, you know. So he exploited that. So this is another thing that, you know, if the machine told us. So I'm coming to not much left, right? Leveraging so how can CAS this thing? I said CAS possesses the domain knowledge and experience for the relevant learning algorithms for identifying patterns. Please use it. You may not be able to go tomorrow and start working on this because first you've got to find one AI team who will work with you, and it's a very expensive proposition to catch AI fellows and work with them. But however, having said that, please remember that the knowledge you possess can be extremely useful to industry, right? Please share it and use that knowledge. Don't just keep it in your mind and go around doing audit the way you used to do it. CAS should work closely with AI programmers and convert their functional ideas to reality. Concepts and thought process can be extended to retail, telecom, insurance, things like that. And you just imagine, you're a finance person, let's say you're in the retail environment, you get a guru in retail, you get a guru in auditing in finance, you get an AI guy, you sit together and you create these learning algorithms. It will be amazing what you will find. It will be amazing, but that handshake has to happen. If the handshake does not happen, each one will be in their silos as usual. Then fraud. I told you this fraud, there's always a pattern and a modus operandi. Then future, all business transactions flowing through, I believe that future, all transactions like I was mentioning, will go through neural networks and it will just throw it out. Even the neural network that we have created, which is running in banks today, we are doing real-time processing. But there is a challenge there, because if you see an example of, like for example, gave you the example of say 20,000 from withdrawn in Guwahati, right, suddenly in someone's account. One is, no core banking system or no bank will allow another external software to stop a transaction. That means to come into their core banking switch system and knock off that ATM switch so that the money doesn't come out. They won't allow that, because nobody allows you to go to core banking system and update. So what you have to do is, you can either send it as an SMS alert that something like this has happened, but to make it absolutely real time by stopping the transaction, you will have a problem for the operational people. Because if, in this 20,000 example I gave you, just imagine, actually, I was in Guwahati and I had an injury and I was taken to a hospital and I withdrew the money for 20,000. And if they had stopped that transaction, right? So the bank will not allow that. So there are some practical things also that you've got to look into. Then, so you can use, and the CS can use all this, you know, you don't have to go and look for the pin in the haystack. Machine will find the pin, you just go and identify whether it's a fraud or not. That's all. By seeing evidence, because it has to stand up in a court of law. So there are these platforms like IBM's Watson Analytics, Google DeepMind, Microsoft Cognitive Services, Amazon, Facebook. Okay, these are the last few slides, but I'll run through it quick. Okay, this is the one on the P2P. Okay, let's take a situation. I've taken very simple examples because so that all of you can relate. Ordering dormant inventory. What is the audit objective? To identify purchase orders that have been placed for items that are dormant or obsolete. What is the business scenario? Vendors want to get rid of their old stock, and therefore purchase managers are sometimes coerced by vendors through kickbacks to place fresh orders for dormant, slow-moving, obsolete stock. And when I was an auditor, I have got this many a time. Many a time people ordering, dormant stock. So there's a kickback. So now in order to find something like this, there's a lot of data that we've got to pull out. Right? We've got to find out when, the date when the item was declared dormant, then the items not sold for the past 6 months is declared dormant, that is the dormancy indicator. Then we have to get all the purchase order info of dormant stock ordered. Then the SOD conflicts, whether if you all know segregation of duty conflicts, right? Whether there is an SOD conflict when that fellow created that purchase order because he may be doing it without anyone else doing it because of the fact that he's getting a kickback. So there could be an SOD conflict when he's working on it. You must know whether there was an unusual time when the order is placed. That means if I have a pattern, my normal working hours is 9 to 5 and this guy is creating purchase orders at 12 o'clock at night from an IP address which is his house. Satyam fraud. Satyam, most of the fraud and the booking of the invoices was in Jubilee Hills in one apartment that these people had bought. Right? So the IP address and all was completely different. It was never done in premises. Okay, so here you can see unusual IP addresses when PO was created. Unusual user creating the PO. That means it is not the normal fellow creating the PO. So if you are trying to create a learning algorithm for this, you will have to do this. Identify dormant items based on dormancy indicator. Identify purchase orders placed for items in item number 1 after the dormancy date. Establish a pattern of burst in purchase orders in terms of number of POs and amount for specific item in relation to the previous period. Then for POs identified in 2, establish whether the SOD conflicts existed at that time when he placed the order. Because he may have had SOD conflict when he created it and he may have told his friend, now set it back. So when the auditor goes, it will be no SOD conflict. Right? So what is SOD conflict in this case? PO creation, PO approval, goods receipt, supply, invoice recording, payment processing. If any two of this is with one person, it is a conflict, right? Then identify unusual time and PO was created, identify unusual IP addresses and PO was created, identify unusual user creating PO. These will be the inputs in my neural network. Now you get it? This is the input that goes into my neural network, which will do all these calculations for me, right, and identify the patterns. Now this is another one, price differential for favored supplier. In this scenario, vendors normally reduce the purchase price per item if the quantity ordered is increased. However, in some cases, the opposite happens when the purchase manager wants to favor a particular supplier. The purchase price increases with increased quantity. So like the other one I said, you pick this data and similarly you can create another learning algorithm, like I was telling you there. You identify first all the purchase orders where the unit price increase is directly proportional to the unit purchase price, right? The machine will do this for you very easily, right? So you can do this for every inventory, product ID, purchase orders, then identify the vendors and items where this pattern has occurred. Establish a pattern where the purchase price increases with increased quantity instead of price decreasing. Similarly, you go through all this, identify unusual time of PO, etc. Right? I think you get the idea, right? This is another one, payments to duplicate suppliers. This is a very common thing, right? So here, let me show you the learning algorithm. You identify suppliers with the similar sounding names, similar address, similar TIN number, suppliers with similar phone number. Then identify suppliers any other non-obvious relationship attribute. I don't know whether you know what this NORA stands for. NORA is that all these are obvious, like address, phone number and all that. This is non-obvious relationship attribute. This was actually created by one fellow in the casinos of Las Vegas, right? But now today it's used in identifying this type of things in audit. What it does is, you don't only look for the obvious ones like address and email ID and phone and all that. You also look for things like if A is transferring money to B and B is transferring money to C, is the directors of A and C same? Or is there one director in one of them? That type of thing, which is not obvious. Okay, so fine. So the road ahead. CAs are part of the connected world. Emerging technologies are changing the ways of business. It gives CAs definitely a possibility to automate and de-skill time-consuming and repetitive work and focus on higher-value work so that they can consolidate their role as advisors on finance and business. Then by being informed about new technologies as they evolve and assessing their implications, CAs can minimize the burdens and maximize the benefits to organizations. The profession can exploit technology and potentially change the scope of what means to be a CA. The CFO of the future will need to know as much technology as they do about financial management. CAs must embrace technology to be relevant in the profession and to ensure sustainability and growth in the digital era. Okay, so this is our name, ICAI. It has CA and AI in the three last words. Thank you very much.
Thank you, sir. Big applause, members. On behalf of members present here, on behalf of Managing Committee of Babu Branch, I'd like to thank CA Babu Jayendran sir for handling the session on understanding artificial intelligence and its use in analytics and Audit. A big applause, members. I request CA Rajesh to come forward and present a memento on behalf of all the members present here. everyone can take a lunch break. So reassemble at exactly 2 p.m. Since sessions are as close 2 minutes early, we have 2 minutes buffer time.